Welcome to Module 2, Introduction to Pointers. In Module 1, we have covered how program memory works, and now it's time to introduce pointers. Pointers are one of the most powerful and unique features of C, and understanding them will open up a whole new world of possibilities for your programs. In this module, we will start with the basics. We will understand what exactly pointers are and how to use them, and how can you perform pointer arithmetic to navigate memory efficiently. By the end of this module, you will be comfortable in using pointers to access and manipulate memory efficiently. So let's get started. So what exactly is a pointer? Pointer is a variable that stores the address of another variable. In other words, pointer doesn't store data like numbers, characters. Instead, it stores the memory address where data is stored. Let's understand this with the help of an example. Let's say we have an integer variable int I equals to 10. We discussed in the module 1 how to represent this in memory. Let's say 1000 address is reserved for this variable. It is denoted by I and the value is 10. How do we declare a pointer? Asterisk or star symbol is used to declare a pointer in C. Let's declare one pointer int star p. This int star p statement tells compiler that p is a pointer variable which stores the address of integer variable. How do we represent this in the memory? Again, p is a pointer variable, so there will be one address associated with it. So let's say the address for p is 2000, and to begin with it contains garbage value. But as per definition, we know that p should store the address of one integer variable in this case. And how do we get the address of I? In earlier session, we discussed that we can use ampersand operator to get the address of variable. So let's assign i's address to p. P equals to ampersand I. With this statement, the address of I, which is 1000, is kept here. And this 1000 address is pointing to this value. This statement declares a pointer, and this statement initializes the pointer. Now let's talk about pointer dereferencing. Dereferencing a pointer means accessing the data stored at the address that pointer is pointing to. So how can we access this value 10 by dereferencing the pointer? To access the data at the address that pointer is pointing to, we use the star operator. This is called a dereferencing operator. If we want to access this value 10 and print it, we can write statement like this: printf %d, star p. So in this case, pointer p is holding this 1000 address, and the star p will access the value at a location 1000. Now let's understand these concepts with the help of code. Now let's write code to understand. Here I have declared integer variable I. This printf will print the value of I, and this printf will print the address of I using this ampersand operator. Let's compile and run the code. Here, as you can see, I value is 10 and address is this value. Now let's declare one integer pointer int star p, say, and let's initialize it. P equal to address of I. Let's print the pointer value. Printf value of pointer percentage p comma p. Now let's print the address of pointer variable. Printf address of P percentage P comma address of P. Now let's dereference this pointer P and print the value of I through pointer. Printf dereferenced value percentage D. How do we dereference pointer? Using asterisk operator, which is star P in our case. Now let's compile this program and analyze outputs. Let's run it. So when we declare this integer variable I, it is associated with this memory location. Address of I is this location. So let's write 5D0C here. This is the address of I variable and its value is 10. So let's write 10 here. And what is the value of pointer P? Value of pointer P, let's say this is a pointer P and its value is same as this address. So 5D0C. What is the address of pointer? Address of pointer is 5D10, 5D10. So here as you can see, pointer variable has its own address and the value is pointing to a different address. In our case, it's pointing to a I variable address. So when we dereference a pointer using star P, it should print the value at this location. So in our case, value at this location is 10. So it will print value 10. Now let's see what will happen if we don't initialize this pointer. Let's comment this line. Any guesses how program will behave? Will it work or will it crash? What will be the output? Can you guess? Let's compile this code and run it. Let's run it now. If you notice carefully here, our code is crashed with this segmentation fault. We will discuss more about segmentation fault in some other video, but here our code is crashed, right? We have not initialized the pointer value and while dereferencing the pointer, code is crashed because it is able to print the value of I, address of I, value of pointer and address of P till this point, and while dereferencing, code has hit segmentation fault. So code is crashed. So we have to be really careful when handling the pointer. We need to make sure that it is initialized with proper address. Otherwise, code will lead to a crash or undefined behavior. A pointer can also be initialized with a special value called null. Let's initialize this pointer with null. P equals to null. A null pointer is a pointer that does not point to any valid memory address. It is a safety mechanism to avoid accessing random uninitialized memory locations. Setting a pointer to null is a good practice, especially when you are not sure if the pointer is pointing to a valid location. So we can check the pointer whether it is null or not before dereferencing it to avoid undefined behaviors and crashes. So here we can write statement like if P is not equal to null, then print. Now if we compile this code and run it, code doesn't crash, P pointer is null and we have a proper check so that it bypasses this statement. You will understand the real benefit of null pointer when we discuss advanced pointer concepts in subsequent modules. Now let's understand pointer arithmetic. Just like you can perform arithmetic on regular variables, you can perform arithmetic on pointers too. Using pointer arithmetic, we can navigate through memory locations, especially in arrays or dynamically allocated memory. Let's understand pointer arithmetic with the help of one example. Let's say we have int I equals to 10 and then int star p is equal to address of I. Pointer p is holding the address of I. Let's say i's memory location is 1000 and its value is 10 here. And let's say pointer p's address is 2000 and its value is 1000, which is nothing but the address of I. Now what will happen if we increment pointer by 1 p plus plus? What will be the value of p after this? Is it 1001? No. When we increment a pointer, it increments by the size of type it is pointing to. In our case, pointer p is pointing to integer type. Let's say integer size is 4 bytes. So when we increment the pointer p by 1, its value will be 1004. Always remember that incrementing a pointer increases its address by the size of type it points to, and similarly decrementing it decreases the address by the same amount. Now let's understand pointer arithmetic with the help of array. Let's declare one array int a containing say 5 elements 1, 2, 3, 4 and 5. What happens in the memory when we make this declaration? Assuming the integer size is of 4 bytes, 20 bytes will get reserved in the memory. 4 bytes for each of the 5 elements. And all array elements will always be present in contiguous memory locations. For example, we have this array A containing 5 elements 1, 2, 3, 4 and 5. Let's say the start address of array is 1000. Then address of this location will be 1004. This location will be 1008. For this location 1012 and this location will be 1016. Now let's declare an integer pointer int star p. Let's initialize this pointer p with the base address of first element. So p equals to address of a of 0. Now let's write a simple for loop to iterate through the array using pointer. For say int I equals to 0, I is less than 5, I plus plus, and let's print the value of each element using pointer. Print f percentage d p plus I will give the address of next location in each iteration. And how do we dereference the pointer? Using asterisk. So when I value is 0, the pointer is pointing to the first location. When I value becomes 1, it will point to the next location, which is 1004. When I value is 2, it will point to 1008. When I value is 3, it will point to 1012. And finally, it will point to 1016. Whenever we increment a pointer, it points to next location of its type. Now let's write code to understand this in more detail. Let's write code to understand. Here I have declared an array containing 5 elements containing values 1, 2, 3, 4 and 5. Now let's declare a pointer variable int star p of integer type. Now let's iterate through the array using pointer. Now let's iterate through the array and print its values using pointer. Let's write simple for loop for int I equals to 0, I is less than 5, I plus plus. Now let's print the address of each element and its value using pointer. Printf address percentage p comma value percentage %d. How do we get the address? P plus I. And how do we get the value? Star of P plus I. Now let's compile this code and run. Let's take a look at this output carefully. This is the address of very first element of the array, which is the address of 1, and each subsequent address is incremented by 4, and these are the corresponding values at each address. So whenever the pointer is incremented by 1, the address is incremented by 4. Here is the quick summary of key pointer concepts in programming. In the next session, we will learn about advanced pointer concepts. Thanks for watching and see you in the next session.